All right, so in this free response assignment, there are definitely a little bit of a different take on some questions, not totally straightforward, just plug in this value or calculate this or use your z-score table. And I think they're good practice. They're not always easy or obvious, but they're good practice to kind of help you practice that kind of a skill. I think our actual AP questions this year will have some of these kinds of things mixed in just to practice them. So in this first problem, they tell you that the median for one high school is 6, the median for the high school is 7. You've got to figure out which is which. Well, high school A has 200 data points, so the median is going to be right between 100 and 101. When you have an even number of things, the median is going to be the average of the two right in the middle. High school B has 221 people, so the median will be the 111th data point. And what we're going to do in both cases, to figure out which is which, is we're actually going to just count our way through the bars. So, and I know it's a little bit hard to tell because they don't have every single individual point marked, but this first bar in A has 46 people in it. So there's 46 teachers who have between 1 and up to 4 years. There are 48 teachers in the second bar. That total only gets us to 94 data points. So if the median is supposed to be between 100 and 101, the median for A must be somewhere in this third bar. We don't know exactly what the exact value is, but we know it's in the third bar. Well, this third bar starts at 7 and goes up to, doesn't include 10, so it's really 7, 8, and 9. So that can't be the median of 6 then. So A must have the median of 7. If we jump over to B and we look for the 111th data point, there are 79 points in the first bar. There are 34 points in the second bar. We've already passed the 111th point. That's 113 people in those first two bars. So the 111th data point must be in this second bar. Well, this second bar only goes from 4 up to 7. It doesn't include 7. So any value in this bar has to be a 4, a 5, or a 6. So the median for B must be 6. So you can look at my wording here or on the written one. It's not so much that you have to have exactly any words, but you need to explain and support why the median for A is 7 and why the median for B has to be 6. B is a little bit more of a straight math one. They tell you, so high school A and the data we have in those graphs has 200 teachers, but they're telling you here there are 18 teachers that were not included with that 200. And they tell you the mean for that 18 is 2.5. They told you in the question the mean for actually both A and B was 8.2. What they want to know in this question is what would be the new mean for the combined 218 teachers. Well, we're kind of just using the formula for mean, but backwards. The mean always equals the total divided by the number of people. So here, the 8.2 must equal whatever that total was divided by 200, and we can solve by multiplying. So the total for the 200 there in the graph is 1640. For the group of 18, they told you that the mean was 2.5. We know there are 18 people in that group. So if I want to get the total for the group of 18, I can just multiply 2.5 times 18. So now I can get the grand total for all 218 people just by adding those. Divide by my total number of people, which is 218. The average for the total group must be 7.73. So you're kind of working backwards for the mean of 200, backwards for the mean of 18, so we can add and divide to get the new mean. In part C, they tell you the standard deviation is 7.2 for high school B, and they want to know the probability that a randomly selected teacher is within one standard deviation of 8.2. Now, one big word of warning. Do not use your z-chart. This question is worded like problems we've done before. What's the probability of being within one standard deviation of the mean? But these two distributions are definitely not normal. They are both skew right, so we should not use the z-chart. But they gave you all the information you need. If our standard deviation is 7.2, within one standard deviation, we can just take the mean minus 7.2 and the mean plus 7.2. We just need to count how many teachers there are from 1 to 15.4 years. And the numbers in this data set are all integers. They told you they're only going to record these values as integers. So we really just need to count all the way up to this point, and that total will be how many teachers we're talking about, how many people we're talking about. Well, if you look at those bars, and I know this is kind of faint, but if we add together 79 plus 34 plus 28 plus 29 plus 19, that will give us our total number of people that are within one standard deviation. And then we just need to take, and we want a probability, so there's 189 people when you add those up, divided by the 221 people total in that high school, and that will give you your probability. All right, in this second question, part A, they give you some information about a particular, or about the time to run the 40, and they say, based on the relationship between the mean, the standard deviation, and minimum time, is it reasonable to believe the distribution of 40-yard running times is approximately normal? Well, the idea here is if it were approximately normal, we should be able to take the mean and add and subtract the standard deviation, probably 2 at least, if not 3 times, to kind of figure out the distribution. But they tell you the absolute minimum lowest score is 4.4. Well, if you look at the z-score for 4.4, that z-score is only negative 1.33. And if these were approximately normal, they're not, but if they were, and you look up a z-score of negative 1.33, that would mean there should be almost 10% of the data below that 4.4. But there's not any. There's no times lower than 4.4. So if this is the lowest score, which only has a z-score of negative 1.33, then this distribution cannot be approximately normal. Now, that is only one way to argue and to support it. You would somehow need to use these points as a reference, but there might be other ways that you could explain it. As long as you use those as your support, you should be fine. If you're not sure, if you want to ask about something you have, please send it to me. I'm happy to break down individual cases and look at what you have if you're not sure. B is a little more straightforward. They say, calculate and interpret the z-score of a player in this position if they can lift 370 pounds, and they gave you the mean and standard deviation for players at that position. So, calculate the z-score. Now, we're not doing anything with the z-table. All we're doing is talking about what does that z-score mean, or interpreting the z-score. A z-score just tells you how many standard deviations above or below 0 your point is. So here we would say, this means that a player that can lift 370 pounds is 2.4 standard deviations above the mean for all players at their position. Sorry, I forgot the decimal. I guess the only thing else I would add there is make sure you do it in context. If you just said this means that 370 is 2.4 standard deviations above the mean, that you would get dinged for. Make sure you include the context of what we're talking about in this problem to ensure you get full credit. All right, so then in C, they give you the values for 2 players. They tell you their time to run the 40 and the amount of weight they lifted, and they want to know if they're only going to pick one of the 2 players, which player should they pick? Well, the idea would be take the means and standard deviations we've learned and figure out their z-scores. Because the z-score will tell you how they compare relative to the rest of the distribution and the mean for each of these characteristics. And if we look at these, player A they're both below average for running time, and they're both above average for weight lifted. But player B is higher above average for how much weight he lifted. And even though he's below average for running time, he's less below average than player B is. So even though I'm just using the z-scores, I can tell that player B would be the better choice because he's even further above average for weight lifted. He's less below average than player A for running time. Please note, we should not use percentiles in the normal table and go to calculate probabilities here. Because we already know those running times are not approximately normal. That's what we proved in part A. And even if we hadn't done that part A, they definitely didn't tell us they were approximately normal. So we shouldn't just assume that we can go all the way to probability, and we don't need to. We have enough information right here just knowing where they compare to the rest of that group of players.